Today's training is going to be on Collabora's MSO test, focusing on the visual difference aspect. So the idea is that PDFs from Word and Writer should produce identical results, and so if we overlay Writer's PDF on top of a red-colored Word PDF, then any red that shows through suggests that something is wrong. And then we want to apply this idea against a whole bunch of different examples and see if we can find any regressions. So here's a diagram of the idea. We're going to start from the bottom up. We take a document and we use Microsoft Office to create a PDF of it, and that will be our authoritative PDF. We'll also take the same document and send it to Collabora Online and have it create a PDF, and that will be our import PDF of how Collabora sees it. And then Collabora will also save that document as an XML format. And then we'll send the XML formatted document through Microsoft Office and create a PDF. Again, that will be our export PDF. So that is the MSO test part of it. It's just creating the PDFs. And the part we're going to focus on today is the comparison of those PDFs in a companion tool. So let's first think about what we're doing here in terms of what our import and export are comparing. If we look at the export, the thing that's changing is the file that we're looking at. The authoritative was looking at one document, and the comparison is against a different kind of document. But the things that are the same is the operating system, the application, which is Microsoft Word, and Word's PDF writer, and the fonts that are available. All of those things have stayed the same. The only thing that's changed is the document. In virtue of that, we would expect that our a PDF comparison should be pretty good. There shouldn't be a whole lot of alternate factors coming into play. When we look at the import comparison, everything is basically switched around. So what's staying the same this time is that the file. We're comparing the same file, but everything else is changing. So perhaps the operating system is changing to Linux, which is the case when we're running Collabora Online and Docker. The application's changed using Writer and Writer's PDF capabilities, and then the fonts that are available will depend on your situation as well. There's a lot of different aspects coming into play here that could create red differences. And other sources of change that we can get, if there's any datetime fields or any kind of randomness, the different environments might select different fonts, and that will very much change the outcome of the layout of the document. In terms of the intent and design of this tool, this tool is designed to only find regressions. So all reporting is going to be done based on comparing two different versions and identifying the relatively worse results. So for example, we would compare Collabora 2304 with Collabora 2404. So we're intentionally trying to ignore any long-standing bugs. The idea with this tool is to find recent unreported bugs, regressions basically. Okay, so here's an example of the kind of thing that we're talking about. Okay, in this case, the authoritative version is in red. So there's a bunch of red showing through, and that's showing a regression. And then after we fix it, then our comparison looks much better. Running MSO test itself to generate the PDFs is quite simple. The only thing we really have to worry about is the settings in our config file. So MSO test will run separately on Word documents, Excel documents, and PowerPoint documents. And so those are the three options that can be provided to the choice application. The base directory is where it's going to find the files and put the output results. And then we can run this either against an online tool like Collabora Online, and provide it with a web URL, or we can say this is false and provide it with a desktop binary version. Okay, so let's just see a demo of this running in action. Running the MSO test is a fairly simple operation itself. It's just a C# program, runs on Windows. And the only thing that we have to do is provide a download folder. We have a download folder with some documents in it. And the config that we're going to use, in this case, we're not going to use the online version. We're going to use the desktop version. We just run MSO test. And as this runs, it will go through all the documents that it finds in the download folder and do a conversion of them. And it creates a converted folder and puts the results in there. Okay, so if we look in our download folder, we see the authoritative Microsoft version of the original document. And in the converted, we have the import PDF from Collabora. Collabora has taken the document, imported it, and created a PDF of how it looks. It's also round-tripped the document into XML format. So now we have an exported docx, and we send that round-tripped document to Microsoft Office again, and Microsoft Word will look at Collabora's round-tripped version of it and make a PDF of what that looks like. And now we just simply have to take these results and analyze them with the Python tool, and that will be done on a Linux machine to run the Python script. Once we have the PDFs, we have a second Python tool that will help us to analyze that. The Python tool will do a page-by-page comparison of the red pixels, and like one of the images we saw earlier, it will automatically generate one of those overlay images if there's more red pixels showing than before, which would suggest a regression. And it will also report anomalies, like if there's a difference in the number of pages that have been output. And of course, it uses the MSO test PDFs as its input. And so running it is quite simple, and the command line to do it is shown here below. Okay, so let's see some of that in action. Once again, running this tool is not very difficult. In the MSO test Git repository, we've just provided some of the files that we got from our MSO test. So a copy of the source files, the download folder, and then a couple of conversions, the conversion results that we want to compare against each other. We'll run our test from the previous version, which the tool will expect by default. We could also specify an exact folder if we wanted with the command line option. We'll simply run the tool against the file that we want to compare against, and it will create some CSV output and images. Now that the tool has finished its analysis, we can look at the results in the converted folder, and we have a bunch of import and export image comparisons that result from it. So we have image for the current version and for the previous version. And here we see the red pixels that our whole tool is, all of our reporting is based on. The red pixels in this case represent the authoritative Microsoft Word, and our results are overlaid over top in grayscale. And so for the first half of the document, the overlay is pretty much perfect. But then towards the bottom, we start separating a little bit, spilling over onto the next page as well. Okay, now we've gotten to the previous image, and the first page looks about the same as before. But on the second page, we used to be much closer. The other image will require a bit of a mental shift. Here we have a three-way overlay. So our current version is going to be in red. The blue is the previous version, and the grayscale is the authoritative word output. And so the purpose of the comparison images is to highlight any regressive areas. Any red showing here would indicate where we're different from previous. If we go back to the first page and highlight it, we can see that we're pretty much keeping in track with the previous, up until we get to this date and time field where we have differences of Tuesdays, Wednesdays, and Fridays, year of 2024 and 2025. Okay, so obviously those are going to be different. And now we can see also the reason for why the next page looks so bad, and that was because previously, because the date was so long, it wrapped around and took up 2 lines, and so the bottom of this page matched the authoritative version. But now we only take up 1 line for our date and time, and that means that everything is shifted up 1 line. And so this ends up being a false positive. There's no real regression that happened here. It's just other factors that have come into play. Okay, and then lastly, we have some CSV files that were put in the working directory, which is the previous one. And so in the Git repository, we have a template that we can use to analyze the CSV files. There's an instruction page telling us how we should use this. And so I'll just I'll go through the steps in the instruction page, which includes inserting the CSV file into a sheet. We're going to do an analysis on 2 sheets separately, the import and the export separately. So this is the import sheet. I'll copy and paste the information. Paste special so we don't mess up the formatting in the template. And go to the analysis column and copy in the analysis formulas here. And this analysis formulas are really the only thing that we're interested in on this sheet. Pixels are separated into content or background status. And the red pixels is an indication of how many red pixels have bled through from the authoritative PDF. And we compare that with the previous run, and then this analysis column will help us to focus on the pages that we should be looking at. So when we sort by the differences, and it's indicating that page 2 has a lot more red now than it did before. And so these are the ones that we would want to focus on. Then the last piece of information is the anomalies CSV. And that just gives us information about page counts. If there's a page count difference. There should be 11 pages, but there's only 10. Okay, so that's basic, just a quick overview of what we're getting from this tool. These are the aspects of the tool it's giving us. So back to the presentation. Okay, so let's just start off with a sanity check to see how well the tool works and what some of the limitations of it might be. And we can do this by comparing Word to itself. So let's just leave Collabora out of the equation entirely. So we can use the tool to do a comparison where we make the authoritative the December version, and the import can be the January one, and the export one will again be the exact same PDF as the authoritative one. So let's take a look at what that would look like in the reporting that we get from our tool. Alright, so here we are in the tool and an analysis sheet that's already been filled in. Let's just get a little bit of our context here for our bearings. The total number of pages that we're working with is about 30,000 pages. And in those, we have 1,200 pages that have had some kind of red pixels showing up, even though the identical application and file have been looked at just at different times. The first thing I always like to look at is the anomaly page, and here it tells us a bunch of files that have page counts different than each other. So let's look at one of those examples and see why that is. So from the download folder, we can get our authoritative PDF, and that one is 2 pages long. And in our converted folder, we get one that's 3 pages long. We can see that the font looks quite different. Okay, so we have some kind of a different font substitution depending on different days. Okay, one time it used a Times New Roman, and the other one it chose this Sylphane one. Okay? So that's one sense where we can't necessarily trust our authoritative PDF when it doesn't have the fonts available to it. The results can be somewhat random. If we look at our Analysis tab, and look at some of the ones that I wanted to highlight. The first one that I want to look at is one that's very interesting, where it seems like we're capturing the text in motion as it's being laid out. Okay, so this is on the 5th page, and all along we have been tracking along quite well, and then all of a sudden it jumps to being almost off by 2 lines here. So I'm pretty sure that what's happening here is that we're capturing a PDF before Word is idled, has come to a final layout. And we can find something similar with Smart Justify example. And so if we look at a comparison, so then we see that there's a different amount of justifying going on here. Okay, so we can't necessarily trust that what we have in our authoritative PDF needs to be justified the same way in our own documents. Similar can be seen in this particular example that I've run across a number of times. This one here, where it's wrapping around the contour of a shape, and so that can be slightly different depending on the time that it's captured. And then finally, around images and other shapes, it's fairly easy to get some kind of a red pixel outline. And so either it's in layout being captured, or else the final result might end up being off by 1 pixel one way or the other. Okay, so those are some of the false positive kind of situations that we can run into. Those are the instances where we're not terribly concerned about when we might have a few red pixels showing. And now back to the presentation. Okay, so now it's time to look at one of the real tests where we're looking at regressions in LibreOffice 25.2. So our download of authoritative PDFs is Word 2019. Our convert folder is going to be the very recent 25.2 master, and the previous convert will be the branch point when 25.2 just started. So let's take a look at the results from that in MSO test. Here in MSO test, we have converted oldest and master for 25.2. And I have the spreadsheet all imported already. The first thing that I always do is look at the anomalies page. I find that about half of the bugs can be identified on the anomalies page because we're checking layout differences here, and often there's enough documents where a layout difference is going to push the content out to another page. So we go through here, and if there's any document that I look at, I will copy the name and colorize it in the main sheet so I don't have to look at it again. Then my second step is always to just browse through all the compare images that have been created by the tool. It's the easiest way to find documents with problems. So I'm just browsing through. The blue is the previous old results, long-standing issues, and any red that shows up is going to be something current. Okay, so here we see some red showing up. We can assume that this one is going to be a problem, and we'll mark it in our spreadsheet as a problem. 504, 506. And actually, I've already marked this one as okay. And so that gives a good opportunity to highlight one of the other images that we haven't looked at quite as much. Okay, so we have a problem on page 2 where we have an extra line of text. We search for that document. And we can look at the import, just the simple overlays. The red in this case is the authoritative Microsoft. And so the first page looks pretty good. And in the second page we have basically our content is pushed down. So Microsoft has the content starting one line earlier. And now we're on the previous version. And we can see a bit more red on the first page. So the red in this case is the authoritative, and our black tends to be 1 or 2 pixels higher than the Microsoft one, and that would have left just enough space on the bottom to fit a carriage return here. So there's some ultimate kind of problem, but this was not actually a regression. It was actually a fix. Because in the current version, our first page is tracking almost identically. We mark all of those pages as okay. So in the spreadsheet, we can have up to 10 pages, and so every time we analyze a document, we want to mark it so that we don't go through it again. Okay, so once we've done those 2 steps, then we can just go through and work our way down the list. And any documents that we haven't looked at yet, we can walk through these one by one and tediously check them all. We'll copy that and search for those documents. Here is the master version of what it looks like right now, and the previous version, oldest, it looked like before. We have a really significant change here. So that one will need to be investigated. Actually, turns out to be one of my commits, so I need to look at that more. Okay, so then we will filter and mark that one as analyzed and a regression, and we just continue on down the list and tediously check them all. So as you can see, there's a number of these must be false positives because they've been marked as good, and yet we've seen a number of regressions as well on this top list. So it's relatively decent at identifying documents or pages that have items that need to be checked out and reported upstream. So we'll go back to the presentation. So just some statistics about this. We're using this against approximately 13,000 separate docx and doc. So we're getting about 30,000 pages of comparisons being looked at. Each part takes about 48 hours to do a full run, so it takes quite a while to generate the PDFs and to do the analysis. And as you can see, the work is fairly tedious to go through the results, but it's definitely helped to find quite a few bugs that nobody has reported yet, bugs that have affected a lot of documents, and that is now being reported upstream and being fixed. So just again, quick summary that this is nice, but it is a quite labor-intensive quality assurance tool. We've seen a number of instances where we can get false positives where the red doesn't indicate a substantial issue. And of course, the same bug can crop up many times over different documents, and so there's a bit of duplication of effort finding the same bug time after time. But that's also a good indication of how important the bug is, and a good validation that there really is a problem that needs to be fixed and reported upstream. Some closing thoughts. All of this is publicly available as open source on GitHub. And although we've been using this special Windows MSO test to create all the PDFs, there's nothing magical about it. Any way that you can create a PDF can be done. Part 2 can be run without actually having our Part 1 and all the infrastructure that takes. Another tip is that the Python script has a fairly lengthy documentation at the beginning that indicates how it can be used, what commands, the commands can be copied and pasted for running it against the 13,000 documents. And it also has a static list of recurring files, documents that have no value in being analyzed time after time that keep giving false positives, especially date and time related documents. Those can just be added to the list and ignored, so they're not continually being looked at. To avoid doing the same comparison over and over, or finding the same bugs over and over again, it's fairly useful to avoid overlapping comparisons. And personally, I think perhaps one of the most useful possibilities of this tool is to verify risky individual commits. So we can run this test on a before and after a single commit and see what kind of side effects it has that we weren't expecting. So thank you. If anybody wants to get involved in this or use it more, feel free to ask me questions and get some extra tips on how to use it.